Good morning, students. Welcome to online class. Today, the chapter we are going to study is matter in our surroundings. Matter in our surroundings. So, we will be studying matter in our surroundings. And let's see what we have to study in this chapter. The first topic which we have to study is what matter is. Matter is anything that has mass and occupies space. Matter is anything that has mass and occupies space. See, where space is written in place of space, sometimes volume can also be written. So people may define matter in the form of substance which is occupying volume and has some mass. Let's see, there are certain examples, several examples which have been shown over the screen. For instance, helicopter, fresh water, and steam which is coming from soup, this clock, they are all examples of matter. Similarly, several other examples can be seen. eh, You, you can see at your place. Next is characteristics of matter. What are the characteristics of matter? The first one is particles of matter are continuously moving. That's right, the particles of matter are constantly moving. This is number one. Particles of matter are continuously or constantly running or moving. See, this can be proved by taking an example of copper sulfate and it is thrown into water. See, this beaker is having water which is colorless, and colorful copper sulfate when thrown into it. So it is observed after a certain period of time the whole beaker gets blue color. Why does the beaker containing water get blue color? It is due to the characteristic of particle of matter, that the particles of matter keep running, and here copper sulfate particles keep running throughout the beaker and they make the water blue. This was first characteristics of particles of matter. We will see next, it is particles of matter attract each other. That's right, the particles of matter attract each other, and this is number two. See, this is second characteristics, that the particles of matter will attract each other. It can be seen from this chalk. We can observe, you must have seen these chalks in your classroom, in your school, and you must have some time try to break them into smaller pieces. You require force. It means you need to spend or apply some energy. Why is it so? Because the particles of these chalk, they are attracted by a force of attraction. See, one more example can be seen. If you hammer an iron ball, it is not broken down into smaller pieces. On the other hand, if a chalk is hammered, it is broken down into a smaller piece. What does it show? It shows the force found between the particles of chalk is not in the same manner as found in case of an iron ball. Obviously, it is large in case of an iron ball. Third is the particles of matter have space between them. The particles of matter have space between them. This is number three. This is our third characteristic. So we have to observe now how can we prove the particles of matter have space between them. Let us see, we are having a beaker which is having water, and we have added 1 tablespoon of sugar into it. So after a certain period of time, what do we observe? The particles of sugar, they have been disappeared within the beaker. See, we have taken certain amount of water into this beaker. Let us assume we have taken 50 ml of water and 1 tablespoon of sugar has been dissolved into it. So sugar particles are no longer visible. Where have they disappeared? So they have gone into the space found between the particles of matter. And it is possible because the particles of matter, I mean, in this case, the particles of water have space between them where the particles of sugar has gone. Now, classification of matter. See, we can classify matter in one of the two ways. We can classify matter either on the basis of physical properties or on the basis of chemical properties. On the basis of chemical properties, matter can be classified into two categories. Either it is called pure substance or impure substance, or some would say mixture. But as of now, we are more interested for physical classification. In the rest of the chapter, we will be talking only of physical classification, and the chemical classification will be discussed in the next chapter. See, on the basis of physical properties, matter can be classified into solid, liquid, and gas. That's right, matter can be classified into solid, liquid, and gas on the basis of physical properties of matter. Now see, matter has been classified earlier on the basis of its physical properties. So one is gas, the other is liquid, and the finally last is solid. See, what do we observe after observing this diagram is at molecular level how they look like. See, in case of gas, the particles are far apart. On the other hand, if you look closely, the particles of matter, if matter is solid, they are very closely packed, as can be seen by this diagram. But in liquid, it is moderate, neither too far nor very close. Now let's compare the three states of matter or the properties of solid, liquid, and gas. See, we will see them one by one. First, we will be discussing volume. If you talk of volume, so solids have definite volume. Solid has definite volume, while liquid also has definite volume. On the other hand, gas does not have any definite volume. What does that mean? If you're having 50 ml of water, it will remain 50, whichever container you take. Similarly, if you're having any solid which is weighing, for instance, 5 gram, it is having certain volume. Its volume will remain as such. But in case of gas, if you take any amount of gas, it will fill the container, whichever container is available. Next, the density. In case of solid, they are having very high density. Why so? Because density equals to, you must be knowing, mass upon volume. That's right, density equals to mass upon volume. And because volume, we have seen volume is very, very small in case of solid, so density becomes high. In case of liquid, density is also high, not as high as in case of solid, but yes, it is also high here. In case of gas, density is very low. Why so? Because volume is very large in case of gas. Next, we will be looking at compressibility. Yes, in case of solid, they are not very compressible. You can take whichever solid which you get at your place and try to compress it. You will not be able to do so. In case of liquid, they are not very compressible, but yes, more than solid. But in case of gas, they are highly compressible, and that is the reason you compress, or you must have seen the cylinder, LPG cylinder at your place, in which petroleum gas, liquefied petroleum gas is there. The gas which is generally butane, it is liquefied or it is compressed, and it can be made to go inside that cylinder. So we have seen volume, density, compressibility. Now let's look at shape. So solids have definite shape, they retain their shape, but liquid, they take the shape of the container. For instance, if you are having different shapes utensils and you keep on adding the same amount of water, every time they will be having different shape. Similarly, gases also take up the shape of the container, so they don't have their fixed shape. Let's see the next It is change of state of matter. See, you have to keep in mind you can change the state of matter by one of the two ways, either by changing temperature or by changing the pressure. Let me repeat it. You can change the state of matter. When I say state of matter, I'm talking of solid to liquid, liquid to gas, gas to solid, gas to liquid. So they can be done by either change in temperature or change in pressure. See, solid can be changed into liquid and the process will be called melting. Once you change solid into liquid, the process will be called, it will be called melting. And when liquid changes into gas, the process will be called, it is called, yes, vaporization. If solid changes into liquid, melting. Now let's go in the reverse direction. When gas changes into liquid, the process is called condensation. That's right, condensation. And when liquid changes into solid, it will be called, yes, freezing. But what? When solid changes directly into gas, the process will be called sublimation. And what? When the gas is changed into solid, it will also be called sublimation. Now we have to see melting. Melting is a process when solid changes into liquid. Yes, when melting is that process in which solid will get converted into liquid on heating. If you heat and you find that the solid has been converted, that process will be called, yes, that will be called melting. And in melting process, you have to keep in mind there would be a temperature at which the process will be taking place. The temperature at which a solid substance starts melting and changes into a liquid at atmospheric pressure. That's very important to mention. It should occur at atmospheric pressure. Then that temperature will be called melting. Or in simple terms, you can understand the temperature at which a solid goes into liquid at atmospheric pressure, we will call that temperature as its melting point. For instance, the melting point of water is 0 degrees Celsius at 1 atmosphere. See, here we have written heating. It means temperature has been increased. So these two processes, one is melting and the other is boiling, which I'm going to see now. These two processes are taking places by changing temperature, and we are increasing the temperature. See, the process of conversion of a liquid into gaseous phase by heating. It means I am again changing the temperature. The process will be called boiling. The process is called boiling, and the temperature at which this takes place, the temperature at which a liquid boils at atmospheric pressure, that temperature will be called boiling. In simple terms, you may also say the temperature at which a liquid starts boiling at atmospheric pressure, that temperature will be called boiling point. For instance, boiling point of water is 100 degrees Celsius at 1 atm. Next is freezing. See, the next topic which we have to discuss is freezing. Freezing, the process of conversion of a liquid into solid. But see, the temperature, the condition of temperature is slightly changed because now we are cooling. Earlier in the two processes, we heated, but here cooling is taking place. Sorry, the process of conversion of a liquid into solid by cooling is called freezing. So if you see a liquid gets freezed, the process will be called freezing, and it will be taking place by lowering down the temperature. See, the temperature at which this takes place, I mean freezing takes place, that temperature will be called freezing point. For example, freezing point of water is 0 degree centigrade or Celsius. Next is condensation, the process of conversion of a gas into liquid. See, gas has been converted into liquid by again cooling. It means temperature is being lowered down. The process will be called condensation. One more thing which you have to keep in mind that's very important. This is a note. The physical state of a substance can be changed either by changing temperature or by changing the pressure. I repeated it because it's really very important. See, the next is, thanks for watching.